Today's video is going to be dealing with the general conic form of ellipses. And so we first want to talk about what an ellipse is. It's a set of all points in the plane such that the sum of the distances to fixed points, called foci, is a given constant. So every conic section can be written in this form here: ax squared plus by squared plus cx plus dy plus e equals 0. And we have an ellipse if your x squared term and y squared term are both the same sign, but a and b are different numbers. Okay? And so an ellipse can be drawn two ways. It can be drawn to where it's stretched horizontally, or it can be drawn stretched vertically. If it's drawn stretched horizontally, then in the standard form, the a squared term will be under the x squared term. If your ellipse is drawn vertically, then the a squared term will be under the y squared term in the standard form. And both of these are the standard form, except you just need to pay attention to where the a squared term is located. And we have a formula for c that we can relate to a and b, and it's given as c squared equals a squared minus b squared. So once we get the standard form, we would have to describe the ellipse using three things. First, we need the coordinates of the center. Two, we need the coordinates of the vertices, where you have 4 vertices total. You have 2 vertices, one to the left and one to the right of the center. And then you have the other 2 vertices, one at the top and one at the bottom of the center. And then 3, you need the coordinates of the focus points, or the foci, which are 2 points. One is on either to the left. One is to the left of the center, and one's to the right of the center in the blue ellipse. And then if you have the red ellipse, you have the focus points, one at the top and one at the bottom of the center. So let's do some examples dealing with ellipses. So what we want to do is we want to write this in standard form by completing the square. And so first thing we need to do is we need to collect all our x's and y's together. So we have 9x squared plus 36x plus 25y squared minus 150y equals negative 36. So we're going to move the negative 36 to the right side. And then you want to factor out the a and the b from each group. So when we factor out this 9, we're going to have x squared plus 4x plus blank plus 25 times y squared minus 6y plus blank equals negative 36 plus 9 times blank plus 25 times blank. Now we're ready to complete the square. So to complete the square, we take half of our middle term and then square that result. So half of 4 is 2, and then 2 squared is 4. Here, take half of negative 6, which is negative 3, and then squared, that's 9. So we're going to add those same quantities over here. So now we want to go ahead and simplify this equation. We have 9 times x. Take half of your middle term, which is half of positive 4 is 2, and then squared. And then the same with this. Write your y, take half of your middle term, which is negative 3, and then square that. And then you're going to simplify the right side, and you're going to get 225. Now, to get the standard form, we need to make this a 1. So we need to divide both sides by 225. So we're going to divide the 9 x plus 2 squared by 225. We're going to divide this 25 times y minus 3 squared by 225 and 225 by 225. And we're going to get x plus 2 squared over 9 plus y minus 3 squared over, I'm sorry, that's not 9, that will be 25. and this one is a 9, and this equals 1. So at this step, we got the standard form. So now we will want to compute A, B, and C. And so we have A to be, it's the bigger denominator. So find the bigger denominator and take the square root of it. So A is square root of 25, which is 5, which means B is square root of 9, which is 3. And C will be square root of 25 minus 9, which is going to give you square root of 16, which is 4. And so now we're ready to describe the ellipse. So what we want to do is find the bigger denominator, which is the 25, and it's located under x. So it is stretched horizontally. So let me do this here. So it's going to be stretched horizontally. It's going to look like this. Let me draw it without the. So it's going to be stretched like this. And so here's our center. Center's there. We got a vertex there and there. So vertex there and there. And then we got a vertex here and here. And then we got our focus point there and there. Okay. So we're ready to describe our ellipse. So it's an ellipse with center -2, 3. And next we're going to find our focus points. Let's find those. So with actually our next thing, we're going to find our vertices. Our vertices, because it's stretched horizontally, I want to add A to my x coordinate of the center. So when I add, so I'm going to add 5 to my center, and I get 3, 3. Then I'm going to subtract A from the x coordinate of the center, which is -7, 3. Then I'm going to add B to the y coordinate of the center, which is -2, 6. And I'm going to subtract B from the y coordinate of the center, which is -2, 0. So there are my vertices. And then my focus point, or foci, what I'm going to do is I'm going to add C to the x coordinate of the vertex, because remember our ellipse is stretched horizontally, so I need to add C to x. So that's going to give me 2, 3, and then I'm going to subtract C from my center, and that's going to give me -6, 3. So here's our ellipse here. All right, here's another example. So we're going to do the same thing as before. We're going to group our x terms together. And then I'm going to subtract the 4. And then I'm going to factor out my A and my B. So here I'm going to factor out the 4 here. And I'm going to put a blank here. I'm going to factor out, well, really there's nothing to factor out because there's nothing from the y squared. So that's y squared minus 4y plus blank equals -4 plus 4 times blank plus blank. Now I'm ready to complete the square. So take half of 2, which is 1, square that, that's 1. Take half of -4, that's -2, and then square that's 4. And now we're going to simplify this. We have 4 times x plus 1 squared plus y minus 2 squared. And when we simplify that, we get 4. Now we need this 4 on the right-hand side of the equation to be a 1, so I'm going to divide everybody by 4. And that gives me x plus 1 squared, and I'm going to put the 1 here so you can see the denominator. Y minus 2 squared over 4 equals 1. So now my A is going to be square root of 4 because it's the bigger denominator, which is 2. My B is square root of 1, which is 1. And my C is square root of 4 minus 1. So here we get C to be square root of 3. And that could happen. You could get some irrational numbers here for C. So that's going to be interesting when we write our description of the ellipse. So because A squared is under the Y term, that means our ellipse is drawn or is stretched vertically. So I'm going to label my different parts. So there's the center there. My focus point is here and here. And then I got a vertex there, and then vertex there, and vertex there. So we're ready to write our description of the ellipse. So it's an ellipse with center -1, 2, vertices. So what I want to do, because it's stretched a certain way, I have to be careful how I handle A and B. So what I'm going to do first is I'm going to add B to my center, add B to my center of the x coordinate of the center, so that gives me 0, 2. And then subtract B from the center, which is -2, 2. And then add A to the y coordinate of the center, which is -1, 4. And then subtract A from the y coordinate of the center, which is -1, 0. Focus points are foci. What I want to do is add C to the y coordinate of the center. That gives me -1 plus 2. I'm sorry, -1, comma 2 plus square root of 3, and then -1, and then I'm going to subtract C from the y coordinate of the center as well, which is -1, comma 2 minus square root of 3. And that will be the description of the ellipse. Here's the last example. And so again, the process is still the same. We want to group our x terms together, group our y terms together. And then this time I'm going to add 16 to the other side. So now I'm going to factor out my A and B. So when you factor out the B here, you get y squared minus 8y, and then we'll go ahead and put a blank there. But you're going to notice that I have one blank. And the reason why I have one blank is because the x squared term does not have doesn't have another x term with it. It's missing the dx term, so we don't have to worry about this part here. So I'm going to complete the square, and this time I want you to figure out what goes in the blank. And if you said 16, that's correct. So now we're going to factor. So this factors to y minus 4 squared. And then when we try to simplify the right-hand side, we get 8. Now I want to divide both sides by 80, because I need that to be a 1. And when I divide by 80, I'm going to get x squared over 16 plus y minus 4 squared over 20 equals 1. So here my a is going to be square root of 20. And that simplifies to actually 2 square root of 5. My b is square root of 16, which gives me b equals 4. And then c is going to be square root of 20 minus 16, which is square root of 4, so c is 2. So now we're ready to figure out what this ellipse looks like. And this ellipse is stretched vertically again, because our bigger denominator is under the y squared term. So here's my center, my focus, here's my focus, my vertices to the left and to the right of the center, and then above and below the center as well. So we're ready to describe the ellipse. So we have an ellipse with center 0, 4, vertices. So what we're going to do is, because it's stretched vertically, what we want to do is add a to the y coordinate of the center. So that's 0, 4 plus 2 square root of 5. And then we're going to subtract a from the y coordinate of the center, which is 0, 4 minus 2 square root of 5. And then we're going to add b to the x coordinate of the center, which gives us 4, 4. And then we're going to subtract 4 from the x coordinate of the center, which is negative 4, 4. And then our foci, we're going to add 2 to the y coordinate of the center. That gives us 0, 6. And then we're going to subtract c, or 2, from the y coordinate of the center, which is 0, 2. There is our ellipse. That concludes the video on general equations of ellipses. If you have any questions, comments, or concerns, please feel free to reach out to me.